It's on.
Hi. How are you?
Oh, I think that's my stomach. I'm sorry. I haven't had lunch yet. Okay. Good morning, and welcome to our October 2022 series of lunch talks presented by the Tempe History Society. And we're glad that you're all here, and those that might be watching while we're streaming, thank you for your attention too. A couple of things: we have expanded our lunch talk series because of their popularity. In the past, we did it October to April, and now we're doing it from September to May. And we think that gives us a lot more opportunity to present some very interesting speakers. The lunch talks, we are thrilled to say, are presented by the Society and Friendship Village in Tempe. Do we have some Friendship Village folks here today? Thank you for coming out. Fantastic. Appreciate that. And with that, let me introduce to you Mark Young, who is the Director of Marketing at Friendship Village, and he would like to offer a bit of a welcome to you. Mark?
My name is Mark Young, and I'm the different
Maybe 5
perspectives
years
offered by
now.
many speakers.
5 years? And with that, let me know when Mark is done. Oh, he's done. If you know how to, Brianna, rotate one of the cameras over to you and then turn around and wave. Brianna King is handling our technology, and she's been doing actually an incredible job. Dan Miller, who was our phantom at the museum for 140 years, he was here before the building was constructed, put together all of the displays and did all of the technology at the museum, and he had the gall earlier this year to retire. Of course, now he double dips because occasionally he comes back to the museum as a consultant, and as a taxpayer that really irritates me. But Brianna has taken over, and is really embracing this technology. And if you get a chance afterward, you can go over and see what kind of work she has to do there. So we thank Brianna. All right, let's get into the meat of the matter. And we're more than delighted to welcome the ASU School of Earth and Space Exploration. This is one of the sciences that really interests me. When I was young, I had no interest in the past. That was for old people, and I wanted to be in the future, and my real goal was to be an astrophysicist. And I got a lot of people through basic astronomy classes at my alma mater, the University of Minnesota. And then it got into mathematics, and I realized I had no math skills at all. Hello, Mr. Mayor.
Hello, Mick. No, I didn't want to interrupt. I just happened to see everyone and wanted to come by and say hi. So, hello. You've got a much better moderator than me and Vic Linoff. So.
Nice to see you. You wouldn't interrupt. You walk in like the mayor of the city or something, in a suit and tie.
See you all.
Nice to see you. So I wanted to be an astrophysicist because I was always interested in astronomical figures and heavenly bodies. But as I say, it just didn't work out. Theoretical astrophysics really is an exciting field. And even today, although I am not qualified, I consider myself a theoretical astrophysicist, and that seems to get me by. All right, without further ado, I am really interested in today's program, and I first want to introduce a student at ASU. David is a senior, correct? Senior. David Ordaz Perez, and he's an aspiring aerospace engineer and currently in his 4th year at ASU. And I've read this before, and I'm not sure that it's in English, but I will try to muddle through this. David envisions a future where he uses his skills to aid extraplanetary missions striving to design successful descent control systems for lunar landers and launch vehicles. Are you taking notes? He will share his research on studying the aerothermal loads experienced in spacecrafts when ascending out of the atmosphere and finding ways to mitigate these effects. Are you following me? Apart from being a NASA space grant internee, and he's got a great shirt. I'm going to steal that before the end of his presentation with the NASA logo on it. He serves as a team lead for the Sun Devil Satellite Laboratories CanSat team that competes in an international competition launching payloads from rockets tasked to measure specific quantities. Does that have anything to do with football? No, okay, sorry. And he's also an intern for the Interplanetary Initiative Laboratory working on a CubeSat known as LightCube. His focus is on the power subsystem, and he conducts tests on flight cells and battery boards. And I'm sure that in his own inimitable way, he will explain just exactly what I said to you in language that we all can understand. David, come on up.
Good morning, everyone. Like he said, my name is David Ordaz Perez. I am a senior at Arizona State University, and today I'll be presenting about our presence as ASU in the space industry. And so, a little bit about me, I guess most of which wasn't already said, is I am from Phoenix, Arizona, so I'm a native here, and I am a first-generation college student. I am a senior studying aerospace engineering, and a fun fact about me is that when I was 11, I wanted to become an engineer after launching a model rocket inside my house. Not that far, but the ceiling went further. And so some of the things I'm going to speak to you about today is the different opportunities that ASU has for students currently for getting involved in the space industry. And one of those is NASA Space Grant. Another one is the Interplanetary Initiative Laboratory. And then the last one is the Lucy Student Pathway Accelerator and Competency Enabler, also known as LSpace. And throughout this presentation, I will just be going over these three general things and how I'm involved with them and how they've helped me. So the first one is NASA Space Grant. And so NASA Space Grant is involved in the school in many different ways. One of the first things is that they provide project proposal fundings, as well as fundings for challenges, competitions, and travel. They also provide research projects and internships for people like me, so team leads can perform different projects for Space Grant and incorporate those within a national or a statewide symposium. And then the very last thing in which they touch is informal education. And so there's events where the interns like myself will go and teach the public basically about the different things that NASA Space Grant does in the space industry or their different projects and what they do. And so how I'm involved with Space Grant is I conduct a research where we look at space shuttle data and we track it. So we run simulations of how it used to ascend and descend, and then we create models on how it was, locations where it would land, and from there look at more of the aerothermal loads. So different types of launch vehicles, different types of rockets are modeled after this successor because it was so successful in its days, and so we're trying to find ways to make those types of rockets even better for our new space vehicles. And so here you see one of the different launch locations. This model I created generally for a small scale scope. This was done last year. It's currently being updated for a larger scale, so these rockets entering the space, or leaving the atmosphere and entering space environments. But the first plot that you see is a general curve of a launch, ascend, and its descend. And then the one next to it is a recovery zone where you create different launch, you pinpoint the different launch locations and the landing locations, and then get a dispersion model to really understand where it is that your vehicle is projected to land. And then from there, go on and create some sort of recovery zone for your team to go and recover the rocket. The next thing that I do is I'm involved with the Interplanetary Initiative Laboratory. And so this laboratory is known as the Space Maker Space. Think about that one more time. The Space Maker Space. And the reason why they call it this is because its mission is to support full life space flight product life cycle, including proposals, designs, analysis, fabrication, integration, and testing operations for space hardware and software that solve society's urgent space challenges. And in this lab, there's two current CubeSat missions that they are developing, one of which is LightCube, which I'm currently involved with, and the last one is known as the Deployable Optical Receiver Aperture, or DORA for short. And these two missions are completely different. First off, LightCube is an outreach mission where it orbits around the Earth. It's set to launch in January of this upcoming year. Our CubeSat will be delivered to NASA in December for them to run last-minute analysis and tests before sending it off into space. And then DORA is set to launch in June of next year. So LightCube, you see a 3D render about it on your right-hand side image, and then the mission of what it does, it's really aiming to inspire and provide a learning experience to people across the planet. And so by having this satellite, people from here on Earth are able to connect to it, and once they're connected with it, have a light flash back to them. So it has a xenon tube that is you run some current through it, and it will then provide a luminescence for you to see while you're on Earth. And this is a simple way for amateur radios to communicate and really start communicating with satellites and having that experience within itself without having those restrictions with other big satellites. And so some of the things that I did was test the batteries for it, where, you know, flight cells, each satellite needs to have its own battery, its own power source. And so what I did was make sure that those batteries were acceptable and ready for space. And by doing that, you have to undergo very vigorous tests where they are cycled through multiple loads and countless of times, and then you put them in vacuum testing, you put them in through vibe testing. And these tests are really meant to simulate space environment and even the launch environment that they experience when they're going up into space. And then the last thing is L-Space, and its mission is to skill up the STEM force workforce for the future. And they're a little bit different in the sense that not only are they involved within the school, they are involved with through other projects outside of the school in the national level. So they provide 2 projects known as Mission Concept Academy, MCA, and then the NASA Proposal Writing and Evaluation Experience Academy. These 2 academies prepare students like me, undergraduates, to write proposals for NASA and basically getting our ideas into a format where we're able to make viable products for NASA to pursue and for us to create. And so the Mission Concept Academy is more of a preliminary phase where you get the first-hand experience, learn the basics about it, and then once you've learned the basics, you move on into the NASA proposal writing, where you actually create the product, you render everything, and then at the very end of this program, you pitch it to a director at NASA Marshall Space Center, where if your design's chosen, you will get funding to pursue this design and basically develop what it is your idea was. And so the current one that you see up there is the lunar pad. This pad is meant to go on the moon, where we are trying to, I say we, but this is not my project. But one of the students the group of students who did this, their goal is to basically have it in the moon and have it as a launch pad or a landing pad for future missions to the moon. And then the very last thing that I will touch upon is SpaceWorks. This one's directly correlated with Arizona State University. It is a class of many different levels, starting from basic level 1 all the way up to 3. And they give you that hands-on experience of how it is in a space flight or a space industry mission project. And so the current one that I will share with you today is a payload that we designed that mimics what the Lucy mission did. And so if I could get a volunteer here, anyone who would like to come up here and basically be my testimony. Whoever. Go ahead, come on. Then could I get you to introduce yourself to the audience?
Okay, my name is Eileen, and I'm just fascinated by the space projects and everything that happens out there in the galaxy.
Thank you, Eileen. And so today what I'll be demonstrating is a basic design of what a camera or a thermal imager does in different missions. And so if you connect to this payload, you'll see that the name of this instrument is called Melvin. And so its basic mission is to take thermal images of whatever target you present to it. And so could I get you on this end? Yes, or your hand.
Oh, in my hand.
Yes, I'll do your hand, no worries. And so what it did at first was calibrate itself as any instrument will in an actual space application. After it's calibrated itself, it's able to now perform its mission. And so we'll have Eileen have her hand above the instrument, and then the shutter will open, take a picture, and then close, and then I will demonstrate the data that you get from it, and then provide you with a plot. So let's go ahead, open the instrument. Thank you. So you see how it opened? Okay, so I'm going to have you put your hand above it, about this level. Could you put it up a little higher so they can, a little bit higher. There you go, that's perfect. And then have it right there. Perfect. Sweet. And so she has her hand above it, and I will now take a picture of it by pressing and giving the command of 3. And you'll see that there's a bunch of data that pops up, and that this is all thermal images of a single point, a single pixel in the image. And we take this, these pixels and then put them in a proprietary program that will then map it from there. You're okay, you can put your hand down, thank you. So we'll close the shutter. See? So we'll take this data, copy it over into this program known as MATLAB. And this is a program that's used in a lot of space industry companies to do a bunch of calculations. We copy it into it, we paste it, and then we run the code. And this is what you'll get. So you'll get a plot. You may have had your hand above it too far. So let's try it again. We'll run your hand a little bit closer to the, yep, that's fine. Thank you.
What is that supposed to show about my hand?
So that's a good question. What does it show? It shows the different temperatures. So you'll get a render of what those temperatures are within the pixel or within the picture. So you'll get an outline of your hand basically as well from this. So let's run it again. Open. I think the mic may have cut off.
We can hear you.
I'm basically going to rerun. I'm going to do the same process again. Thank you. So we'll do the same thing. You're good now. Thank you. We'll close the shutter. Take the data again. And then from there, copy it over into the program to again visualize what it is that we're getting. And so in many space applications, we do the same thing. We get a bunch of data from our orbiter or our imager, and then we then take it and process the data. And so this is nothing that's really out of the ordinary if you apply it in a space application. We seem to be getting the same thing. I know this works. Tested it before this. So like the lunar reconnaissance missions or some of like the orbiters that are going around Mars, they all conduct this process of taking images and sending it back to the ground control stations here on the Earth. And so, well, I guess we can go along with this image, but thank you. So here we see basically a harder image than or a harder object than its surroundings. And so this represents maybe, it could have been her finger that the camera got that wasn't in spec, but basically it's of a hotter temperature, so we're able to identify the object in that sense. And so these imagers in applications for space environments identify different thermal spots in like a planet, in a moon of what they go. And so we use this data to then run analyses to figure out whether or not basically if we're able to go and explore or find different things about it that we didn't know before. But basically this is the small demo and a basic thing that we do here to prepare students to go on into the space environment and into the space industry to prepare them for different opportunities there are and things like that. Are there any questions? Yes.
So what did it show about my hand?
So it shows that your temperature is around 28 degrees 0.5 Celsius of the hottest point in your hand. And so that's around the average temperature of your body. So it depicts exactly what it should.
So the red spot, what you're telling me, is leaving the danger zone?
Not necessarily. It all depends on the application. So if you were, say, orbiting a planet and wanted to land there, you would then find out that that location is specifically hotter than others, and so you can prepare for then to create different objects to withstand those thermal loads and withstand those heating problems that may come with it. Yes?
Back on your project, yours was the cube, right?
Yes, CubeSat.
Okay. How many students are working on that, or?
So there is a total of, I think, 10 students at Arizona State University, and it's being partnered with another company as they give us that guidance, that professionalism guidance. There's two PIs to it, so principal investigators, and they help along the design and anything like that.
So after the batteries are all tested, does it go into space, and then how long does it stay up there?
Yes, so it goes into space. We're looking at integration right now, so we're putting the whole satellite together as we speak. And then from there, it's going to go in space. We approximate around 3 years in space, in orbit for 3 years.
David, a general question about space. I'm astonished that it's been 50 years since we were on the moon, early 1970s. Have we lost a lot in just staying away from there and going further into space? Are we missing out?
That's a good question. You know, we think about a different analyses and we look at what we gained and what we learned from back when the Apollo missions were very evident and very frequent. I would say there was a lot that was missed, but you know, we're ramping back up with the Artemis missions, and that in itself is very exciting for students like me, people in the industry, because it's really revamping a mission of studying the outside, everything out of Earth in that sense.
I think we'll get to that question in just a minute.
Yes, Meg will go over.
All right. Let's thank David. We'll have a little more time before the end. Now I know why I never got into astrophysics or any of that stuff. My God. So what would it cost to get that shirt?
That is a question for Meg.
You didn't even pay for it?
I don't think so. Did I? No, we didn't. It was given as an intern.
How do you get to be an intern? That's the big next question. All right, let me introduce to you Meg Hufford. And Meg is a coordinator senior at the School of Earth and Space Exploration at ASU. And I should point out, and ASU probably doesn't like that, but Arizona is really a leader through its universities in space exploration. ASU, the U of A, and NAU. And I suspect that despite what the presidents might say, they do work together on various projects. So I just wanted to point that out. Right now, ASU is involved in more than 24 NASA missions and still counting. That's an incredible number. Meg began at ASU in 2003, and she continues to promote the research of the School of Earth and Space Exploration, also known as CC.
That's right, SESE.
Yeah, is that what you really call it? Okay, good. I thought maybe I had coined a new phrase because I hate all these long words. And she works through public outreach, events, and K-12 school visits, creating another generation of science professionals is really important because technology makes quantum leaps from one generation to the next. Prior to March of 2020, the school welcomed almost 10,000 students annually, and Meg is excited to return to safe on-site events and programming, which she'll share with you in a moment, to get a chance to actually tour the facilities there is really a privilege. And she's been a resident of Tempe for 30 years. That makes her an old settler, which is coming up on Saturday. I'll mention that later. She and her husband of 41 years, do you really want to mention all of that? Okay. Are the parents of 5 children, and they're now all grown, and she's very pleased to be here today, and we're delighted to have her in the community that she loves so dearly. Please give a welcome to Meg Hufford.
All right. Well, good afternoon, all. I am truly pleased to be here as a Tempe resident, and I have just a short presentation. I do just want to say a few things about our previous speaker, David Ordaz-Perez. The NASA Space Grant Program has been in effect since 1987 as a way for NASA to seek out and train for future workforce and future exploration. Of all the 50 states, and NASA does have a presence in all 50 states with the Space Grant Program, the consortium here in the state of Arizona is very strong. And it is NAU, U of A, and ASU, and also Embry-Riddle Aeronautic University. So David Ordaz-Perez is an incredible reflection of that program. He and I have known one another for a few years. In addition to the great research that he does, David does have a heart for informal education, which is one of the very important components to be able to address an audience and to not use acronyms or to speak without jargon. It is a goal not to just do science, but to be able to communicate science. In the School of Earth and Space Exploration, we have very strong support from our leaders, from our director, and of course, I also bring warm welcome from our director, Dr. Meenakshi Wadhwa. She has been our director since 2019, and we move through our outreach program with the full support of our leadership. And of course, David is a great reflection of the ASU NASA Space Grant Program. Annually, more than 100 students apply. This year, the program was able to fund 34 undergraduate students. They are paired with a faculty mentor. They work with that researcher for up to 10 hours a week. And there is an informal education component, also rigor. There is rigor in the program. Poster session, symposium, these things that the student can effectively promote, the intern can effectively promote and engage the public in the great research that they're doing. So, for my small presentation here, I have this and I think I know how to use it. So, Eclectic Exploration is the name of my talk today, A Journey in Progress. And I just want to highlight a little bit, not to get historical, let's see if it works, but to get hysterical down. No, let's see. There we are, okay. So in our school, it really is all about space, Earth and space. I work in a building called Interdisciplinary Science and Technology Building 4, and the shortened version of that is ISTB4. Prior to 2006, I forgot to ask, are there Sun Devils in the group? We have any Sun Devils in the group with us? I hope by the end of the talk today, there'll be a little Sun Devil in all of us. But you may know that Arizona State University has a long history in our community as a territorial teachers college in the 1860s. Arizona State came along in 1958, and it has been an amazing journey. So I guess I'll just move forward. Let's see. It is also about time, once upon a time, and I'm going to take you back to the year 1957 when Sputnik launched. Anybody? I also launched that year. So it's a good year for me, and Sputnik, of course, did a little more than start the conversation, wouldn't you say? Prior to NASA being established in 1958, it was known as the National Advisory Committee for Aeronautics, or NACA, and that was the seal, what I'm showing you on the screen now is the seal of this organization. It morphed into, oops, let me go back. It morphed into this emblem or logo from 1915 to 1958. Additionally, as we moved toward 1958, the National Aeronautics and Space Administration was established. That was a pretty good day. We have Technicolor as the seal and the logo progress. Who remembers the worm in the 70s? From the 70s to the 90s, I'll go with it, but it's very futuristic. You still see that font sometimes. To the meatball. Currently, the NASA meatball, as it is affectionately referred to, is a symbol that it exudes pride, discovery, exploration, and we're very, very fortunate at Arizona State University to have these legacy missions of exploration and discovery of our dynamic Earth, of Earth's moon, and way beyond. The Mercury missions hail back to the 1960s when we were challenged by John F. Kennedy, an American president, to bring an astronaut to the moon and then return them safely to home. And mission patches really tell a story. We went from Mercury with one sole astronaut to Gemini with 2. And then we moved to the Apollo missions. In fact, we are celebrating 50 years since astronauts walked on the moon. We will celebrate the 50th anniversary of Apollo 17 this year. An iconic image from Apollo 11, when astronauts first walked on the moon, and Apollo 17 in December of 1972. Arizona State University, I use the year 2003 because that's the year I started there. And since that time, many buildings, many research facilities, and many amazing students have passed through Arizona State University. And for my little journey, I began working for the Mars Education Program. And in the year that I began, in 2003, you may recall, there were twin rovers sent to the surface of Mars, Spirit and Opportunity. In testing, it was hoped that these rovers would run for 90 days. A component I want to add to the discussion today is that there would be no robotic exploration without human exploration. And of course, David is giving us great ideas for what's ahead for us. I worked at the Mars Space Flight Facility, which is an amazing 1930 adobe structure on the campus. In fact, the only adobe structure. It was completely repurposed for the exploration of Mars. Professor Phil Christensen is a renowned geologist, loves the rocks. He loves rocks on Earth and on Mars, but he had some ideas about how to study them. And so Professor Christensen is the principal investigator of 5 instruments that have made their way to Mars. And the returns of science research have been so fruitful that many of the instruments that he has helped to build are now, apart from Mars, they're doing similar research at other planetary bodies. I'll tell you about Europa Clipper in a minute. Mars exploration continues to send a spacecraft as a flyby, to place orbiters around a planet, to place a lander or a rover. These are all components that have been successfully completed by NASA, but there is no way that we are done. So this just shows you the various families of Mars exploration, from flyby to orbit to lander to rover. In 2007, right next door to the Moore Building, now called Interdisciplinary A, NASA decided to return to the moon, and Professor Mark Robinson joined the Arizona State University faculty and is the principal investigator of a 3-camera system that has been orbiting the moon now for 13 years. Lunar Reconnaissance Orbiter launched in June of 2009. It is the return of data is combined. It's more data than all NASA missions combined. They are returning petabytes of data. And so the moon is, just for clarification, the moon is my favorite planetary body. I suppose you could say that I am a lunatic. I've been fascinated by the moon in all of its phases since I was very young, and to be part, even a tiny part of this mission. It's a very amazing thing. So an example of some of the data, this is the lunar orbiter, it's failing me, lunar orbiter laser altimeter. Thank you very much. So by sending a laser and continuing to measure the distance between the spacecraft and the surface of the moon has been re-imaged to tell us where the highs and the lows are. I want to bring your attention to the south pole of the moon, where one of the largest impact basins in the solar system is placed, and that is South Pole Aitken Basin. It is a region of interest and ROI for many, many researchers, as it's believed that there are permanently shadowed craters. In fact, with the mapping and imaging of the surface of the moon for 13 years, there are definitely permanently shadowed craters, and it is believed that there would be large quantities of water. And we are waiting for the Artemis mission, fast forward to today. We are waiting for Artemis to go because it will lead us to the next time that there are boots on the moon, and of course we're very excited about that. And so in the secondary payload of Artemis, in addition to all the other science that it's going to do to successfully return us to the moon, in their secondary payload, this spacecraft carries small CubeSats. The Lunar Polar Hydrogen Mapper, or LunaMap, is a small CubeSat about the size of a large cereal box with solar panels. And that was proposed by a postdoc who is now a professor at ASU, and his name is Craig Hardgrove. The CubeSat was built entirely in ISTB4 in the Clean Labs, and we are waiting anxiously for Artemis to go for many, many reasons, and we do wish them success. So that is a blank slide, I don't know why. So this is the building, Interdisciplinary Science and Technology Building 4. It is located on the Tempe campus. We are celebrating the 10th anniversary of this building. I can remember scurrying past that empty parking lot for a while. But the building was dedicated in October of 2012, and here we find ourselves in October of 2022. And really, time and space, it continues on. The architecture of this building is very unique for a research facility. The building is wrapped on two sides by laboratories, but these laboratories are available to be viewed by the public. The first and second floor of ISTB4 is open to the public, and it features full-scale models of spacecraft and instruments, a glassed-in mission operations area where Professor Jim Bell is currently overseeing 2 cameras on board the Curiosity rover and 2 cameras on board the Perseverance rover, which are newly arrived, relatively speaking, to Mars. It is also the location of the Center for Meteorite Studies. In 1961, the Center for Meteorite Studies was established at ASU. It is the largest collection at a public university on the planet, and I really hope that there's an opportunity for you to come and visit. A portion of this collection is now beautifully displayed on the second floor. In 2019, the center was renamed the Busek Center for Meteorite Studies to celebrate Professor Peter Busek, a renowned researcher at ASU.
What building is that next to? I can't picture it.
At the intersection of Apache and Rural, and you go a little further north to Lemon, where the rural parking structure is, ISTB4 is the first building west of the rural parking structure. You just can't miss it because it's 7 stories high. I'm going to give you a reason to come and visit us shortly. So this brings me to an event that's happening this Saturday. In terms of outreach, things have been quiet since March of 2020, and as Vic mentioned, prior to March of 2020, we welcomed almost 10,000 K-12 students on site. And we love hearing the pitter-patter of little feet, and big feet as well, in the gallery. And so part of my job description is that I recruit and hire and train those students that will provide guided tours of the first and second floor of our building. Additionally, on the first floor of ISTB4, there is a 230-seat auditorium. It's called the Marston Exploration Theater. We are very, very happy to have our benefactor, Susie Marston, who she's kind of an angel to us. She provided the funding to make the Marston Exploration Theater a reality. In addition to the students, the younger students seeing these amazing full-scale models of spacecraft and instruments, mission operations in situ, and also looking into these clean rooms on the first floor of our building, NASA clean rooms where instruments are built and tested for space flight. There are many projects, as David mentioned, as students move through their career. The most recent triumph, I would say, in our gallery of scientific exploration is a full-scale model of the Psyche spacecraft. As I mentioned, the school has legacy for missions that are ongoing, and we are also anticipating the launch of several missions, and this includes the Psyche mission. Psyche is the name of the mission. It is the name of the destination. 16 Psyche is a metal-rich asteroid in the outer belt, and our former director, Lindy Elkins Tanton, will be the second woman to lead a NASA Deep Space Discovery mission. We are so excited about it. It is theorized that perhaps Psyche is the exposed core of a protoplanet that through a series of unfortunate events in the early formation of our solar system, the outer layers were collided off. And so this is an exposed metal core, and what would that look like? And so Lindy, I know she would want me to send her greetings as well, wants this to be everyone's mission, and we're very, very excited as we anticipate its launch sometime around mid-2023, so I hope you'll keep your eyeballs on that. The flyer that you see now in the presentation is for Earth and Space Exploration Day. This is now in its 26th year. It is the signature outreach event of the School of Earth and Space Exploration. This Saturday, it will run from 10 in the morning until 2 in the afternoon. We will feature researchers, student clubs, there will be demonstrations, and in addition, there will be 3 3D astronomy programs in the Marston Theater. Let me share that this is not a movie. There is a pilot, there is a presenter. The content is created and presented by Arizona State University students. My colleague, Rick Alling, we have worked together for 14 years. He has trouble remembering that number. I'm not sure why, but for 14 years now, Rick has been uniquely placed to manage the Marston Theater, and I expect that most in this room have seen the dome-type planetarium where you gaze up. In the Marston Theater, it is a flat-screen planetarium. There are glasses that you put on, and you're not watching a movie. Every data point is where it should be in this amazing 3D demonstration. And so on Saturday, there will be 3 3D Marston programs. The Busek Center for Meteorite Studies, it is one of 2 days where the center will identify whether your rock is a meteor right or a meteor wrong. This is a service that was offered by the center until 2010. Anyone in the group remember Meteorite Men? Those 2 guys, the Meteorite Men, they would go to these undisclosed locations, and so everyone thought they had a meteorite, and they started to send in their samples, and it just became untenable for this. So the service was suspended in 2010, but there are 2 days a year where the center will invite the public to bring in their meteor rights or their meteor wrongs. I will say in the course of the history of the event, 1 meteorite has been determined, and there are broken hearts along the way, but we choose to go and keep looking for meteorites. All right, so I will make sure that I provide Vic with this flyer, and I hope that you will come and visit us. Another point I wanted to bring up regarding the School of Earth and Space Exploration, it is an interdisciplinary school. In fact, a transdisciplinary school in that geologists are speaking to engineers. What? Now, prior to 2006, the university structure was departments. Prior to 2006, there was the Department of Physics and Astronomy, looking up at the stars. And over here was the Department of Geological Sciences, looking down at the rocks. And the engineers were over there somewhere and really not talking to anyone, with no disrespect to any engineers that may be in the audience. In 2006, the School of Earth and Space Exploration was established. The camaraderie, the research, the collaboration has been astounding. And so from that, there are many, many collaborations with private business. There are incredible facilities that have been built. Our faculty is second to none. And of course, the facilities are amazing. And this all is for the purpose of our students. And that's what really it is all about. And I want to just point again that David has reflected that in a very wonderful way. So this Saturday from 10 to 2, I'm going to invite you all to come down to the campus. The event is free, it is family friendly, and we have missed having people in our gallery, but we have not been idle during the COVID pandemic. We have a magic planet that has been completely reprogrammed, the content built by ASU students. We have a full-scale model, which up until March of this year was the Curiosity rover. There are 11 changes that have been made to the Curiosity model, and it is now Perseverance. We also have a full-scale, though small, model of its exploration friend, Ingenuity. Ingenuity is a helicopter, a proof of concept, please don't call it a drone, that accompanied Perseverance on that arduous journey to Mars. After 6 weeks on the surface, the shield that was protecting Ingenuity came off. At the precise moment, the rover rolled away, not over, but away from, and disconnected the power source. And so Ingenuity was on the surface of Mars, had a short amount of time to charge its batteries. It was hoped that it would fly once. I'm very happy to tell you, as of today, there have been 32 successful flights of the Ingenuity helicopter. It has 2 small cameras underneath. It has served to do reconnaissance for the Perseverance rover, and I think that it will be a concept that moves forward. Now, David's been working on some things that we'll be looking for those as we move into the future. But for today, I just want to close with my sincere thanks to the Tempe History Museum, to the Tempe Historical Society, to Vic Linoff, to Carter Rogers, ever patient with us. And I do invite you all to come and explore with us. I hope that we will cross orbits again. Thank you very much.
A voice from out of the back of the building. A couple of questions. One, has ASU had an involvement with the James Webb telescope that just was launched?
Thank you for asking, Vic. Prior to the Webb telescope, you may recall Hubble still does great work, about 250 miles above the surface of our planet. That 32-year mission is Arizona State University has observing time on the Hubble Space Telescope. Professor Roger Windhorst has been part of that science team. When James Webb Space Telescope launched on Christmas morning, anybody? A shout out to my colleagues that do event planning as the mission was slipped, and on Christmas morning, Webb launched. Unlike the Hubble Space Telescope, which is in low Earth orbit, the Webb has traveled out 1 million miles to the Lagrange 2 point, and its orbit will be very unique. Hubble is a visible light telescope to see in the same spectrum that we do, in the same wavelength that we do. Webb is an infrared telescope, which demonstrates the thermal properties that David, and thanks for your hand, ma'am, by the way, we love the hand. And so there have been some unveilings of recent images that are coming in. Arizona State University has more than 100 hours of observation under the research group of Professor Windhorst, and many of our students will benefit from Webb. We anticipate that we will see the universe as never before, and I do encourage you to stay tuned. The very design of Webb is very, very innovative. It faces away from the sun. It must be in very, very cold temperatures in order to operate. And so the orbit that it will take around the sun will mirror that orbit that Earth takes, except the telescope will be facing out from the sun, and its orbit will be a halo orbit as it moves around the sun. And so I really encourage you. NASA does an incredible job of documenting all of their missions. And I do encourage you to check that out. Additionally, let me say that at the School of Earth and Space Exploration, when we did go quiet back in March of 2020, my colleagues in the community outreach group and our director, our associate director, Professor Patrick Young, devised a virtual night sky program. It has grown wildly in popularity. Every other Wednesday since June of 2020, the Marston Virtual Night Sky program is a Zoom webinar that you can join us for. It is a 1-hour presentation. It features current happenings in the night sky, because we determined that looking up at the sky was something that we could all do together while we were apart. Also, there are current events and ASU students that present regularly. My colleague Rick Alling is the Master of Ceremonies. My colleague Kim Baptista makes it all go smooth as our webinar coordinator. And so the YouTube channel that is available, any YouTubers in the group, if you go to the YouTube channel and do a search for ASU School of Earth and Space Exploration, you will find playlists of each and every virtual night sky program. We have another one coming up next week. I hope you'll join us on Wednesday night at 7 p.m. We have up to 300 people that register every other week. Now, our theater on site seats about 230, and when we had our public program, we could fill the house on very few occasions, but if we had a couple of dozen people. But the virtual component is something that's had wild success, and so I do encourage you to, recently, in fact, we featured the James Webb Space Telescope and the students that are exploring it. So we look forward to Webb and the way that it will reveal the universe to us in a whole new spectrum, in a whole new way.
You talked about meteorites. ASU's collection, if I'm not mistaken, is one of the largest
It is
in
the
country.
Largest collection at a public university.
And
on the
so I would invite people to go unless you want to take a slight detour to Chile and the Atacama Desert. There is a wonderful meteorite museum in the Atacama Desert that I had an opportunity to visit. And that's one of the most examined sites just because of its location, and they picked up a lot of meteorites in that area. I know that ASU has contributed a lot of its graduates to science programs, to NASA. I'm just wondering, has anyone from ASU ever become an astronaut?
Well, let me think. Not yet.
Oh, well, there's something to aspire to.
You know, all those fifth graders that we see, our sweet spot for K-12 is really the intermediate grades. And in the years that that the school has been providing these K-12, we do have students that return and become Sun Devils. And so we're looking for that return on interest and that return on investment, that we hope that there will be astronauts that move forward in the program.
Well, and things have changed so much. In the beginning, really what was desired were essentially test pilots, people with extraordinary physical skills, that sort of thing. Today, experience in various disciplines is much more important. And elderly have gone in. John Glenn flew a second time. He was in his 70s or early 80s, and there have been a couple of other of that age. So it's a much easier journey today than it used to be years ago. So.
Well, Vic, I will add that the 24 astronauts that made their way to the moon, of that number, 12 astronauts walked on the moon. And of the 12, only one was a geologist, and that is Harrison Jack Schmidt. The others were the other 11 were pilots and needed to learn about geology. And not only the state of Arizona, but its universities had a big role in training the Apollo astronauts. As we fast forward, the astronaut program is very, very much in play. It has expanded in scope. There is a lot of diversity within the pool for astronauts, and we certainly encourage that expansion because we're wired for it. Exploration is a human imperative, and I am quoting our former director, Lindy Elkins-Tanton. It is a human imperative, and I hope that we will have a few astronauts as a result of that. Thank you. Yes, sir.
Make a quick question on funding. How much of it is corporate funding? How much is federal funding? How much is other sources? What's the breakdown?
Oh, the F word. Oh. I'm afraid I can't really speak to that. I will say from a business standpoint, New Space Initiative is an entity that is at ASU. It is under Professor Jim Bell, who is a NASA researcher, and it is a way to bring industry and research together. It's very, very important that this collaboration continues and expands through private and international collaborations. I don't have a better answer for you than that, only that ASU will continue to play a role as we do move forward in exploration and discovery.
Getting back to Arizona right now, there are people doing work in northern Arizona for exploration on Mars and the moon, I believe. That was done very early near Flagstaff. In fact, part of the moon's surface back in the Apollo days
Yes.
was replicated through blowing up part of the area near Flagstaff.
Yeah, I don't know how that would fly today, but that's right. In order to provide a track for the vehicle, the lunar rover, because for Apollo 11, 12, and 14, it was all on foot. But for 14, 15, 16, and 17, they had the car. Pretty awesome. So Arizona played a big role in training. Also, right here in our own state, Meteor Crater serves as an incredible analog for the moon, and it is the best preserved crater in the North American continent. A bit of the collection in the Center for Meteorite Studies, the Busek Center for Meteorite Studies, is from the impactor of Meteor Crater. And of course, Earth is dynamic and alive. The surface of our planet doesn't look like it did even 100,000 years ago. However, when we look at the surface of the moon, we look at the surface of Mercury, we look at the surface of Mars, it's kind of a snapshot of the formation of our solar system. Our friends at the Lunar Reconnaissance Orbiter camera have de-evolved the impacts on the moon and gone back in time, and then they bring you forward again to see where the moon is right now. But Earth and the moon at one point were very, very volatile. However, the dynamic forces here on our planet, the mass that we have, that we are a differentiated body with a core and a mantle and a crust, and a very strong magnetic dynamo and a strong atmosphere, places us in the solar system among our neighbors. Everyone remembers when there were 9 planets. I love the 9 planets. Pluto's always a planet in my heart. But of the 8 planets that we explore, we love the moon, but Earth and Mars are the most similar. And Arizona State University has been sending spacecraft and instruments to Mars since 1997 with great, great success. The flyby missions, the orbiters, the lander, the rovers. And we're very, very excited, and we're not done exploring even for a little while. We continue to go forward, and with amazing students like David and the ASU NASA Space Grant Program, and many of the disciplines within our school, we will go boldly.
And just one more. I think you mentioned it, but how many students at ASU, undergrad or graduates, are involved in some way with space programs? It's a big part of the university, is it not?
Currently within our school, there are about 400 undergraduates, about 120 graduate students, about 60 postdocs. Our faculty approaches 80 or 90, could be more than that. And overall, at 5 campuses, I believe the enrollment at Arizona State currently is about 140,000.
Yes. All right, let me.
Does ASU have any involvement in any of the systems and subsystems of Artemis?
I don't know. But the secondary payload is what ASU is focusing on, and that is there are 10 CubeSats in the secondary payload, and one of them was built at ASU. Now, the covering of the mission, we defer to NASA for that, but within that mission, in fact, Artemis 1, there will be four steps of Artemis to get to boots on the moon. But for Artemis 1, it will go through the entire procedure as if it was a crewed mission that people were on board. The secondary payload is kind of a bonus, if you will. And so while we're not strictly in mission operations, the Lunar Polar Hydrogen Mapper is ASU's piece of that mission, and we hope that it goes forward.
And then just one final question too. If for those that want to, I don't know if you call it a newsletter, but get the notices of
Yes.
the various things that you're doing,
Yes.
How do they go about doing that?
So our website, sese.asu.edu. CC, thank you, Vic. Within there, where it says contact us, it's an easy sign up for our newsletter, which goes out, I think it's maybe monthly. And we need a first name, a last name, and an email address, and then you are in the newsletter. You will get notices of the research, you will get notices of upcoming events, and a greeting from our director. And I do hope that you will sign up for the newsletter.
And I know that Meg and David have another, you said it, a Circle K? What are you doing there?
Vic, are you messing with me? Nope, we are in process for Earth and Space Exploration Day, and so it's a very, very busy week. And in fact, it was a great buffer. I don't know if you can hear my blood pressure going down just being in the company of you all, but we are gearing up for our big event on Friday, and so that is why David and I need to be on our way. But I do want to thank you for being gracious to us, asking great questions. My thanks to the organizers. I'd also like to give Brianna a big round of applause for conquering the technology. Okay.
Yes,
right.
and she'll be working on some of the other missions now because she's got that capability of remote cameras, and you'll see her focusing some of the Mars rover cameras.
Thank you all so much. I hope we cross orbits again. Thank you.
Thank you, and,
Thank you so much.
on behalf of and really with thanks to Friendship Village, it won't go very far for all of your research, but there is a contribution to the school from the History Society, and we thank you for coming out today.
My thanks, and a portion of this will go to the ASU NASA Space Grant program as well. My thanks to a wonderful audience. Thanks all, and go Tempe.
Thank you.
What a pleasure. Thanks, Vic.
Whoops.
I'll take one more.
There, okay. All right, before we, I just want to shut that off. Before we wrap up, let me tell you about next month's program. I think this is one that everyone will be interested in. As most of you know, the railroad, when it came to the valley, first came to Tempe. We were 6 months ahead of Phoenix. And contrary to what many believe, we have always been a spur for the railroad because it came up from Tucson to Maricopa and then went west. And it took a lot of lobbying for Tempe to get that alignment. And once the railroad came, there were a number of different companies operating railroads, competing with each other. There were once 4 or 5 depots, all in the downtown area, something that most people don't know. And with the extension to Mesa, there were competing railroads. There was also a second railroad bridge that ran east of the current railroad bridge to the mill, and then on east after that. If you've seen the classic photograph where there's a huge bridge collapse and a railroad engine in the riverbed, it's not the current bridge, it's the bridge that was east of it, and that has been now demolished. So that's kind of a prelude to David Doiron will be here next month, November 9th, talking about the history of the railroads and putting them all into context. But in doing research, so many people have just become confused by the number of railroads that we've got over time. And some other events that are coming up in just a couple of days. October 14th, we have a series of musical events, Lo Mejor de la Música Latina. This is in anticipation of our Yaqui exhibit that will be, I think, opening in November. And the group is called One Way Sky. They'll be here October 14th at 7 p.m. in the room? In this room, okay. And then also, the museum has been featuring community chats. And in these community chats are featured film clips and audio recordings and some group discussions about topics of interest and importance to the African American community in Tempe. And the next one is coming Tuesday, November 15th, the day before I think we get together again. Oh, no, that's after, 6 days after. It's called Who We Are, A Chronicle of Racism in America. There's always lots going on here at the museum. One of the questions I like to ask, how many are members? Very good. Normally, I would tell the others to get out, but we're going to wrap up anyway. But we hope that you'll consider becoming a member. It's very inexpensive, but it's helpful to us because it shows the amount of community support we are getting. And often the society goes out for grants. And the first thing a potential grantor will ask is, how many members do you have? So if we even have to pay you to be a member, we're willing to do that. But we hope you'll consider becoming a member. Again, I want to thank everyone for coming out. A reminder that our lunch talks are now streamed live. And if you got some enjoyment out of today or think someone else should see it, they are archived, and you can go to the museum's website or to the foundation's Facebook page, or the society's Facebook page, and see any of our past lunch talks. And sometimes we're getting an extraordinary number of people viewing them after those presentations. So with that, again, I will thank you. Oh, by the way, it's Halloween. I'm sorry that it's too light in the room. My tie glows in the dark. Are you zooming in on that? Oh, come on, you can do that. All right, that's Brianna. If you're watching it on Facebook, you're seeing it close up, but it glows in the dark. Pardon? Oh, yes. The Old Settlers, if you have been a resident or lived in Tempe or worked in Tempe for something like 30 years, they don't really care anymore. You are considered an Old Settler, and not to be in competition with ASU's event, the Old Settler Annual Picnic is this Saturday. It's at the Arizona Community Church, which is Rural and Knox. It's free. The only thing that they ask, it is a potluck lunch that you bring some food to share, and that's from, pardon? Or a donation. I prefer food. And it runs from 11 to about 2 o'clock. So if you can make that, that's the Old Settlers Lunch picnic, and that only happens once a year. So again, thank you all for coming here today. Thanks to everybody watching on Facebook. We will see you again next month for our talk on the history of Tempe railroads. Have a great day and a wonderful Halloween.
Yeah.